6 weeks. That's all it took. Not the real survey, not the 10-year mission everyone's been waiting for, just 6 weeks of optimization testing, the telescope's version of a warm-up lap. And in that time, it found 380 worlds beyond Neptune. Before this, after 3 decades of searching, astronomers had only catalogued about 5,000. Here's the part that should stop you. A handful of those objects are tracing orbits that shouldn't be possible under the Sun's gravity alone. Something massive appears to be out there, quietly pulling on them. For over a decade, astronomers have argued about what that something is. Now, for the first time, a machine exists that might actually settle it. It started running 7 weeks ago, and the man leading the hunt for this hidden planet is the same man who took the last one away. So what exactly did this telescope find? Trans-Neptunian Objects, or TNOs, icy bodies orbiting far beyond Neptune, out where sunlight is little more than a rumour. In just a month and a half of early testing, Rubin's Simony Survey telescope identified roughly 380 of them. To understand how fast that is, consider this. It took the astronomical community 3 decades to catalogue about 5,000 TNOs total. Rubin added nearly 8% of that entire historical count before its real mission had even begun. 2 of these objects stand out immediately. They are called 2025 LS2 and 2025 MX348, and both sit on orbits so elongated they reach roughly 1,000 times farther from the Sun than Earth does. That places them among the 30 most distant objects ever detected in our solar system. These aren't just distant rocks drifting in the dark. TNOs are fossils, frozen leftovers from the solar system's violent formation, untouched for billions of years. Every orbit is a clue about how the planets moved when everything was still being decided. But finding them is brutally difficult. As one researcher on the Discovery team put it, searching for a TNO is like searching for a needle in a field of haystacks, sifting through millions of flickering points of light to find the handful that are actually distant worlds. Rubin did that 380 times in 6 weeks. And buried inside that batch of new orbits is something stranger than the objects themselves, because a small group of them are moving in a way that shouldn't be possible. Here's what caught astronomers' attention. Among the most distant Kuiper Belt objects ever found, a small cluster of them share something they shouldn't share. Their orbits point in nearly the same direction, tilted at nearly the same angle, like they're all being nudged by the same invisible hand. Statistically, that shouldn't happen by chance. One astronomer compared it to 6 hands on a clock, all moving at different speeds, and then glancing up to find every single one of them landing in exactly the same place at exactly the same time. The odds of that happening randomly are close to 1 in 100. So something has to be sculpting this pattern. And the leading explanation is almost unbelievable in scale. A massive, unseen planet, sitting far beyond anything we've ever directly observed, quietly using its gravity to herd these distant worlds into alignment over millions of years. If it exists, the numbers are staggering. Somewhere between 5 and 10 times the mass of Earth. Orbiting roughly 20 times farther from the Sun than Neptune does. Taking somewhere between 10,000 and 20,000 years just to complete a single trip around our star. This hypothetical world already has a name. Planet 9. And the story of who's hunting for it is where this gets genuinely strange, because the person leading the search is not who you'd expect. His name is Mike Brown. And if that name sounds familiar, it should, because Mike Brown is the astronomer credited with Pluto's demotion. In 2006, His discoveries forced the scientific community to redefine what counts as a planet, and Pluto lost its spot on the list. For over a decade, he's been, only half-jokingly, one of the most disliked men in amateur astronomy. Type his name into any space forum, and you'll find comment threads arguing that Pluto deserves justice, and Brown's name sitting right in the middle of the outrage, which makes what happened next almost impossible to script better. In 2016, that same astronomer, alongside his colleague Konstantin Batygin, co-authored the modern Planet 9 hypothesis. The man who took a planet away spent the next decade of his career trying to find a new one. And of everything the Rubin Observatory might reveal in the years ahead, asteroids, dying stars, interstellar visitors, Brown has said plainly that Planet 9 is the discovery he wants most. The man who closed one planetary case is now standing at the edge of reopening an entirely different one. But here's what makes Brown worth listening to. He's not just hoping. He's already told us exactly what a real answer would look like, and exactly what it would mean if the answer turns out to be no. So why does everyone suddenly think this question can finally be answered? Because Rubin isn't built like any telescope that came before it. Most observatories point, focus, and stare at one target for hours. Rubin does the opposite. It sweeps across enormous sections of sky, revisiting the same patches over and over, hunting for anything faint, slow, and distant enough to have been missed by everything else. Its mirror spans 8.4 meters. Its camera, the largest ever built for astronomy, captures a new image roughly every 40 seconds. Over its 10-year survey, it will return to every point in the sky nearly 800 times. Batygin says this is exactly why the hypothesis finally has a real test. He calls Planet 9 readily refutable, and he's confident that as Rubin collects data through this year, scientists will know one way or another. His standard for proof is simple. If Rubin spots an object hundreds of astronomical units away, on an orbit matching the predicted range for Planet 9, that's the confirmation. At that distance, he says, anything visible to Rubin would have to be enormous. Astronomer Megan Schwamm goes further, estimating that if Planet 9 sits inside the main predicted search zone, Rubin will likely find it within its first or second year of operation. It sounds like the case is nearly closed, but there are two very real reasons this search could fail completely. First, the evidence itself has a crack in it. In July, Japanese astronomers using the Subaru telescope discovered a new distant object nicknamed Ammonite, only the fourth known member of a rare class called sednoids. Astronomers expected its orbit to line up with the other three, the same alignment that helped build the Planet 9 case in the first place. It didn't. Yukun Huang, who ran the simulations, said plainly that this misalignment lowers the likelihood of the Planet 9 hypothesis. His alternative is unsettling in its own way. Maybe a massive planet did exist once, only to get violently ejected from the solar system, leaving these strange orbits behind like fossils of something that's no longer there. Astronomer Catherine Volk is even more blunt. In her words, the evidence for Planet 9 is very weak. Then there's the catch almost nobody talks about. Much of Planet 9's predicted brightness range does fall within what Rubin can technically detect in a single image. But the observatory's current survey plan doesn't extend far enough north to cover the planet's entire predicted path across the sky. Which means Rubin could search almost everywhere it's capable of looking, run for years, gather more data than any telescope in history, and still miss it completely, simply because the one patch of sky where it's hiding sits just outside the plan. This isn't a story about an answer already found. It's a story about a test that, for the first time, is actually possible. Let's step back and look at the scale of what's actually happening. Those 380 objects Rubin found in 6 weeks of testing are just the opening page. Once the full 10-year survey is running at full strength, scientists expect roughly 30,000 more Trans-Neptunian objects to follow, nearly a 10-fold increase in everything we currently know about the outer solar system. Which means, even if Planet 9 turns out to be nothing, this data still rewrites the map of our solar system's most distant, least understood region. And this is where Brown's own framing becomes the most honest thing anyone involved in this hunt has said. If Rubin searches its full range and finds nothing, that's not a failure. In his words, it becomes an important nail in yet another planetary theory, science moving forward either by confirming an idea or by finally being able to rule it out. For the first time in this entire decade-long argument, that's the real shift. Not a discovery. A machine capable of ending the argument completely, one way or the other. No more decades of clustered orbits and competing simulations and educated guesses. Just data, coming in now, from a telescope already running. Which means the answer so many astronomers have spent their careers chasing might not be years away anymore. It might be closer than anyone expected. So here's where we actually stand. 380 new worlds found in 6 weeks of testing. A cluster of orbits that shouldn't align by chance. A hidden planet's fingerprint, argued over for a decade. And now, finally, one machine capable of proving it, or ruling it out for good. We're not saying they found it. We're saying, for the first time, we're actually about to find out. So sit with this. If Rubin spots a bright pinprick hundreds of astronomical units out sometime this year, are you ready to welcome a 9th planet back into the solar system? And if it finds nothing at all, are you ready to let the idea go? Subscribe, because that answer might arrive sooner than anyone thinks.